This is Module 5, Lesson 3. We're going to talk about linear functions and probability. We're going to interpret the equation y is equal to mx plus b as defining a linear whose graph is a straight line. And we're going to give examples of functions that are not linear, okay? Now, we're going to write linear equations to model the relationships, and we're going to determine whether or not a function is linear. All this comes from Eureka Module 5, Lessons 3 and 4. Let's start with Lesson 3 here, linear functions and proportionality. We've seen this equation before. We've seen this data table before. What they're asking us to do, or what I'm asking you to do right here, is to write a linear equation for this. Now, let's go through how to write a linear equation for this. We know if it's linear, it starts with y is equal to mx plus b. Now, our b is where we begin, where we have 0 bags of candy. Looks like here with 0 bags of candy, our cost is going to be $0. Now, all we've got to find is the m, the rate of change. Well, if 1 bag of candy is $1.25 and 2 bags is $2.50, we know our rate of change is the change in y over the change in x. We've gone from here to here, 250 minus 125, that's our change in y, which gives me $1.25, $1.25, and from here to here, 2 minus 1, 1 bag of candy. So it's $1.25 for 1 bag of candy. Our m would simply be $1.25. If you read this, and you don't need to leave the plus zeros there because it doesn't mean anything. When you read this, what this actually tells you is that the cost is going to be equal to $1.25 per bag times x, the number of bags. That's what this means. Now, let's look at the next one, example 2. Walker walks at a constant speed of 8 miles every hour. Constant speed means we're talking about a linear equation. We've got 8 miles every hour. Describe the linear function for the number of miles he walks in x hours. Okay, now we're not going to worry about the range. Let's just write our linear equation. Y is equal to mx plus b. Now, if he's walking and he's walked 0 hours, then we should have 0 miles at that point. Y is our number of miles, x is our hours. Okay, so we need to find our rate. Our rate is 8 miles per 2 hours. If we talk time, time is usually on the bottom, miles per hour, see? Our m would be equal to change in y over change in x, which is 8 miles per 2 hours. I can divide 8 by 2, and that gives me 4 miles per hour. That's the rate at which he walks. Okay, so 4 goes in here for our m. We don't need to keep the 0 in there because it doesn't really mean anything at this point. Y is equal to 4x. That tells us that y, which is miles, the number of miles he walks is equal to 4 miles per hour times the number of hours that he walks, right? So let's say he walks 2 hours. How many miles would he walk? Okay, that would be 4 times 2, which would be 8, right? If he walked 4 hours, that would be 4 times 4, which is 16 miles, right? Okay. Let's look at example 3, and we're going to write a linear equation on this one. Veronica runs at a constant speed. The distance she runs is a function of time she spends running. So we're writing a function, right? The function has the table values shown below. Okay. Now, first off, we need to know if this is linear. Yep, it says constant speed, so we've got a linear equation. Y is equal to mx plus b. B. Well, b would be times 0. If he's run 0 minutes, he hasn't gone anywhere, has he? So b is 0. Y is equal to mx plus b. We need to find our m. We know that m is equal to the change in y over the change in x. Here's our y's. This would be 2 minus 1, which is 1, over, see, we started with 2, so we start with 16 here. 16 minus 8, which is 8. The change in y is 1. The change in x is 8. This means 1 what? 1 mile for what? 8 minutes. He's going 1 mile every 8 minutes. y is equal to 1 over 8 times x. We don't need to include the plus 0 because this doesn't give anything. Y is our number of miles. The number of miles then is equal to 1 mile per 8 minutes times the number of minutes that he runs, right? If he ran 8 miles, it would be 8 times 1 would be 8 over 8, 1 mile. If you ran 8 minutes, you'd be 1 mile, right? Okay? All right, let's look at example 4. Water flows from a faucet into a bathtub. So if here's my bathtub, and I've got water flowing into it. Right? At a constant rate of 7 gallons of water every 2 minutes. Okay, there's our M right there, isn't it? 7 gallons per 2 minutes. There's our rate of change. The bathtub is initially empty. Okay, so it's a constant rate. We know it's a linear equation. Y is equal to mx plus b. Initially empty means b is 0. And we've already got our constant rate. It's 7 over 2. M is 7 over 2. Okay, so our equation is y is equal to 7 halves x. If I divide 7 by 2, I've got 3.5. Y is equal to 3.5x. Now that means that y, what is our y here? Remember, this is changing y over changing x. This means the number of gallons. See, our units tell us what it is. So y is gallons. The number of gallons in the tub is equal to 3.5 gallons per minute times x, which is the number of minutes. Okay? Now, if the tub can hold 50 gallons, how long will it take to fill the tub? Well, where would 50 go? 50 is gallons. Look, if you look at this, y is our gallons. Okay, so we plug this in for y. Right here we go. 50 is equal to 3.5x. If you divide both sides by 3.5, x, the number of minutes, put that in your calculator, 50 divided by 3.5, and you would have 14.3 minutes. It would take 14.3 minutes to put 50 gallons into this tub, okay? 50 gallons, 14.3 minutes, if it's flowing at the rate of 3.5 gallons per minute. Okay. Now assume that you're filling the same 50-gallon bathtub with water flowing at the constant rate of 3.5 gallons per minute. Same tub, okay? Water's coming out, okay? 50 gallons. We need 50 gallons to fill it up. Flowing at 3.5 gallons per minute. Okay, so we start with y is equal to mx plus b. It says it's at 3.5 gallons per minute. That's 3.5 times the number of minutes. But there's initially 8 gallons of water in the tub, so we've got 8 gallons in here. That means the b is 8. Will it still take about 14 minutes to fill the tub? Well, obviously it shouldn't because it's already got 8 gallons in there. But let's see how much it would take. If I'm trying to get this full, 50 gallons, remember y is our number of gallons. We've already done our rate. Y was number of gallons. See, gallons was on top. 50 then is equal to 3.5 x plus 8, and we're looking for 8, the number of minutes. Okay, let's subtract 8 from both sides. 42 then is equal to 3.5 times x. So see, 42 gallons is the total number we need to put in if there's already 8 gallons in there. Divide both sides by 3.5. So we got 42 is equal to 3.5 times x. Let's divide both sides by 3.5. And x is equal to 42 divided by 3.5. 12. X is 12 minutes, okay? That would make sense. 12 minutes to add the additional 42 gallons here, right? Here you're putting 50 gallons in. It took 14.3 minutes. Here you're just having to add 42 because there's already 8 in there. So it takes less than 14 minutes. It takes 12 minutes. Then they ask you to actually fill out this table here, okay? Using this equation, y is equal to 3.5 gallons per minute times the number of minutes plus 8. That means you've already got 8 gallons in there. At 0 minutes, how many gallons do we have in the tub? 8. 3.5 times 0 is 0, plus 8 gives you 8. At 3 minutes, let's plug this in. Y is equal to 3.5 times 3 plus 8. Okay? 3.5 times 3 plus 8 will give you 18.5 gallons. So at 3 minutes, you have 18.5 gallons. At 6 minutes, let's plug that in. Y is equal to 3.5 times 6 plus 8. 3.5 times 6 plus 8 would give you 29 gallons. At 6 minutes, you'd have 29 gallons. Okay? Let's see at 9 minutes. Y is equal to 3.5 times 9 plus 8. Okay? 3.5 times 9 plus 8 gives you 39.5 gallons. Okay? And then the 12 gallons. Let's try that. Y is equal to 3.5 times 12 plus 8. 3.5 times 12 plus 8 gives you 50. Isn't that just what we said it would be up here? 12 minutes would give you a total of 50 gallons if you started with 8 gallons in your tank. Okay? Now, we're still talking about water flowing from a faucet. So now we've got water flowing from our faucet into a tub. At a constant rate, so it's a linear equation. Y is equal to mx plus b. Assume that 6 gallons of water is already in the tub. So now we've only got 6 gallons in, okay? The information is recorded in the first column. At 0 minutes, 6 gallons. At 3 minutes, 9.6. At 5, 12. At 9, 16.8. Let's write the linear equation for this, okay? Well, we've got our b. It starts with 6. We need our m. We need our slope, okay? Well, we know that m is equal to change in y over change in x. So let's find the change in y. Here's our y's down here. See, this is a set of coordinates, 0, 6, and this is a set 3, 9.6. Here's your x, here's your y, here's your x, here's your y. You're finding the difference in your y values. 9.6 minus 6 will give you 3.6. Oops, 3.6. Your change in y is 3.6. How about your x's? 3 minus 0. See, that's what we've got here. 3 minus 0 is 3. 3.6 divided by 3 would give me 1.2. This is 1.2, and see my y's are on top, 1.2 gallons per minute. We're flowing at a rate of 1.2 gallons per minute on this one, right? And we're starting with 6 gallons in the tank. Now, we're going to write a few more linear equations. Let's look at this one. This is mowing an area of lawn. It says that in 5 minutes you can mow 36 square feet. In 20 minutes you can mow 144. 30 minutes you mow 216. 50 minutes you mow by 50 minutes you've mowed 360. Okay, they said right here it's a linear function, so let's write the linear equation. Y is equal to mx plus b. If I'm mowing the lawn, it doesn't say what I've got done at 0 minutes. I must have just 0 amount done at 0 minutes because it didn't say anything about it. Although we could check it backwards and see, okay? We're going to check that in a minute. Y is equal to mx plus b. Our m, remember m is your change in y over change in x. All right? Our change in y, here's our y. Let's use these 2 points. Start at this side, 144 minus 36, 20 minus 50, right? We started with the top number on both of them. 144 minus 36 in your calculator will give you 108. 20 minus 5 is 15. Your y goes over your x, so 108 divided by 15 would give me 4.4. I'm going 4.4 square feet per minute, right? 104 divided by 15. Let me try that. No, it's 7.2. Sorry, not 4.4. 7.2, okay? That's 7.2. Okay, so our equation is y is equal to, and our m is 7.2. 7.2x plus 0. Y is equal, you don't need to keep the plus 0 since it doesn't mean anything. Y is equal to 7.2 times x. Y is your square feet. The number of square feet is equal to 7.2 square feet per minute times the number of minutes. Okay? Now, we're skipping this page. We're going to the bottom of this one. A linear function has the table of values shown below. This is in your workbook. Okay? If we're looking at this table of values, they say the information shows the total volume of water in gallons that flows from a hose as function of time. Okay, they want us to describe what's going on and write a rule. First, let's write the rule, then we're going to describe it. We know that this is y is equal to mx plus b. We're talking about linear equations right now. It says linear. Okay, our b, we don't know what we're starting with in there. We're not sure what 0 is. So let's check to see. Let's find our m first. Let's see. Our m is equal to the change in y over change in x. Here's our y, 110 minus 44, which is 66. Let's find our change in x. 25 minus 10, which is 15. That's 66 gallons in 15 minutes. Okay. If I divide 66 by 15, that's 4.4 gallons per minute. Okay, let's put that in here. Y is equal to 4.4 x plus b. I'm not really sure what b is here. Why don't we plug in a point in C? I've got this point, 1044. Here's my x, here's my y. And let's see, when y is 44, 4.4 times 10 plus b. We're going to find b by plugging in an x and a y. 44 is equal to 44 plus b. Subtract 44 from each side. And your b is 0. So we started out with 0 volume at 0 time. Y then is equal to 4.4 x plus 0. Or y is equal to 4.4 x. I don't need to even have the 0 there, do I? Okay. Let's erase that so we can make that look a little better. Y is equal to 4.4 times x. This means, what does this mean? This means our y, which is the volume. The volume of the water in gallons is equal to 4.4 gallons per minute times what are we talking about? Number of minutes. Okay. this says, what number does the function assign to 250? That is, how many gallons of water flow from a hose during 250 minutes? We're looking for the number of gallons. How many gallons? Okay, well, let's use our equation. Y is equal to 4.4 times X. What are our X and our Y? Let's see. Our X is minutes, our Y is time, is gallons. Okay, so we're looking for gallons, we're looking for Y. Y is equal to 4.4 gallons per minute times 250 minutes. Plug that in, 4.4 times 250. And you get 1,100, okay? That's how many gallons you would get in 250 minutes. Okay, D. The average swimming pool holds about 17,300 gallons of water. Okay, so here we got our pool. It holds 17,300 gallons. Suppose the pool has already been filled about a quarter of its volume. So let's divide this by 4. 17,300 divided by 4. That means we've already got 4,325 gallons in there, okay? Write an equation that describes the volume of the water in the pool if at 0 minutes we use the hose described above to fill the pool. Well, what hose do we have? It was running at 4.4 gallons per minute, right? So let's write the equation. Our linear equation is y is equal to mx plus b. What do we start with? We already got 4,325 gallons in that pool, right? There's our b. And our m is 4.4. Okay, there's our equation. Approximately how many hours will it take to finish filling the pool? Well, if the pool holds 17,300 gallons, that's our y, right? See? Right here, it told you volume in gallons is y, okay? So we put the gallons in there, total volume for the pool. That's equal to 4.4 gallons per hour, per minute, times the number of minutes, plus the 4,325 gallons that's already in the pool, right? It's already quarter full. To solve, we subtract the 4,325 from each side, 17,300 minus 4,325 would give us 12,975. That's still equal to 4.4 times x. Let's divide both sides by 4.4. And x, the number of minutes, would be 2,948.9 minutes. They asked for number of hours. Wouldn't I divide that by 60 minutes? There's 60 minutes in an hour. Divide that by 60. That would mean it would be 49.1 hours. Almost 2 days, right? A little over 2 days. Look at 3. Recall that a linear function can be described by the rule y is equal to mx plus b. Right? What is the equation that describes this function? Okay, let's figure it out. Start with y is equal to mx plus b. We know that our b is where it crosses the y-axis. Sorry, 0b. In this case, we've got the point 0.04. So our b is actually 4. We start at the input of 0. Our b is 4. Now we simply need to find our x, right? I mean, our m. Our m is change in y. over change in X. Let's find 2 points, doesn't matter which two. Our change in Y is 24 minus 4, which is 20. Our X would be 4 minus 0, which is 4. 20 divided by 4, which is 5. Y is equal to 5x plus 4. Now complete the table. If I do that, Y is equal to 5x plus 4. We plug this in. Y is equal to 5 times 15 plus 4. 5 times 15 plus 4 gives us 79. Okay, now let's do 20. Y is equal to 5 times 20 plus 4. 5 times 20 is 100 plus 4 is 104. Now let's do this one. Y is equal to 5 times 23 plus 4. 5 times 23 plus 4 would give us 119. Okay? Now we're going to deal with the problem set. This is the problem set for lesson 5.3, lesson 3 in module 5 workbook. Okay, let's look at our problem set here. A food bank distributes cans of vegetables every Saturday. The following table shows the total number of cans they've distributed since the beginning of the year. Assume that the total is a linear function of the number of weeks that have passed. Describe the function being considered in words. We want to know the total number of cans. We want to know how many cans are being contributed each week. All right? Write the linear equation that describes this. Let's see, we've got Y is equal to mx plus b. How many cans do we start with? Okay. Let's see, total numbers of cans. Assuming the total is a linear function, number of weeks. Total number of cans they've distributed since the beginning of the year. They started out distributing 0, okay? So B is 0. We need our M. M is the change in Y over change in X. Choose 2 points. Our change in Y would be 2,160 minus 180. That would be 1,980 over 12 minus 1, which is 12. 1,980 divided by 12 would give us 165. So what they're saying is you're distributing 165 cans each week, all right? So Y would be equal to 165x plus 0. This means the number of cans you distributed, total number of cans, would be equal to 165 cans per week times the number of weeks that you've been giving them out. Y is equal to 165x. Assume that the food bank wants to distribute 20,000 cans of vegetables. How long will it take them? Well, Y is the total number of cans, right? So you would say 20,000 equal 165 times X. You divide both sides by 165, and X would be 20,000 divided by 165, which would give us 121.2, okay? 121.2 what? Weeks. Okay, that's a long time. All right? Okay, wait a minute. It's got to be more than 165 per week. Let's stop right here. Okay, we're wrong right here. Okay, We made a mistake right here. 12 minus 1 is 11. Okay, so let's fix this real quick. $19.80 divided by 11. We're giving out 180 cans per week. All right, sorry about that, guys. Our equation is y is equal to 180 cans per week times the number of weeks. We should have known that from right here. Week 1, we gave out 180 cans, okay? So let's fix this right here. This should be y is equal to 180x, okay? Now, assume they want to distribute 20,000, total of 20,000 cans would go right here, is equal to 180x. Let's divide both sides by 180, and x is equal to 20,000 divided by 180 would give me 111.1 weeks, okay? The manager had forgotten to record that they distributed 35,000 cans on January 1. Write an adjusted linear equation. Well, if this is the total number of cans, wouldn't we put it this way? Y is equal to 180 cans per week times number of weeks plus the 35,000 they gave out on the first day of the year. Using your function here, determine how long in years it will take the food bank to hand out 80,000 cans. Okay, so let's plug it in. 80,000 is equal to 180x plus 35,000. Let's subtract 35,000 from both sides. That would give us 180x would be equal to 80,000, okay, minus 35,000. That would give us 45,000. Okay, and you divide both sides by 180. And x would be 250, okay? We take 250 weeks, there's 52 weeks per year, divide that by 52, and essentially that would take you 4.8 years, okay? All right. A linear function has a table of values below. It gives the number of miles a plane travels over a given number of hours while flying at a constant speed. Well, that's y is equal to mx plus b. Number of hours traveled, at 0 hours traveled, it will have traveled 0 miles, so that's 0. Y is equal to, we need our m. M is the change in y over change in x. Find the difference in our y values over the difference in our x values. This is 1,700 minus 1,062.5. That's 637.5, and 4 minus 2.5, which gives us 1.5, okay? That's 637.5, our y, over our x, 1.5. And that would give me 425. That means we're flying 425 miles per hour. The equation would be y is equal to 425x. I don't need the plus 0 at this point. Describe the function. This says that the number of miles it's flown is 425 miles per hour times the number of hours. We just wrote the equation. Assuming that the airplane is making a trip from New York to Los Angeles, which is a journey of about 2,475 miles, how long will it take the plane? Okay. Y is equal to 425 times X, number of hours. Okay, total number of miles, 2,475 is equal to 425 miles per hour times the number of hours. Let's divide both sides by 425. 2475 divided by 425 would give us 5.8 hours. X would be about 5.8 hours, okay? If the airplane flies for 8 hours, how many miles will it cover? Well, you'd put the X in for, X would be 8. Y is equal to 425 times 8. 425 times 8 would give me 3,400 miles, okay? Okay. And we're going to skip that one. We're going to skip 3 and 4. And we're going to write 5. Let's see. Let's write the equation for this one. Let's see. Y is equal to mx plus b. Okay. Our b is 6. Y is equal to, and we find our m. Remember, our m is change in y over change in x. That would be, our change in y is 14 minus 11, which is 3. Our change in x is 8 minus 5, which is 3. Okay. Y is equal to, let's see, 3 over 3, which is 1, just 1x plus 6. Okay. There you go. That's that equation. And I think that covers everything we wanted to cover. All right.